Okie dokie, artichoke. So we're going to look now at 4.3e, which involves adding and subtracting fractions and mixed numbers. Okay, so let's look at this first one. It says Anna is 10 years old. Anna is 1.5 years older than River. And then it says Lacey is 4.5 years younger than River. Based on the model, which of the following statements is not true? Okay. So let's look at each statement one at a time. I don't want you to try to well, first of all, we can figure out what each of them is, right? How old each of them is. So first of all, we can just look at the number line. Anna is 10, right? I'm saying Anna like this is frozen. What's wrong with me? Okay, River, let's see what she's lined up with. She's lined up with right here, which would be 8.5. And then Lacey's lined up with 4. So anyone that does not say one of those ages, we can eliminate. Does it say River is 8.5? Yep. Lacey is 4? Yep. Anna is 6 years older than Lacey. Well, we'll look at that in a second. Okay, so now that all those are right, we can keep going. River is 8.5 years old because 10 minus 1.5 is 8.5. Is that right? Yes, it is, because look, we went back 1 from 10 to 9, and then we went back another half to get to 8.5. Okay? So that's true. They went the one that's not true, correct? Yes. Lacey is 4 because 8.5 minus 4.5 equals 4. Well, it says that Lacey is 4.5 years younger than River. So River is 8.5, so 8.5 minus 4.5. Well, let's see. What's 8.5 minus 4? 8.5 minus 4.5. I'm sorry. 8.5 minus 4 would be what? 4.5. And then if I subtract another half, 4.5 minus half would just be 4. So yes, that's also true. Anna is 6 years older than Lacey because 1.5 plus 4.5 equals 6. Well, let's see why they say that. They say that Anna is 1.5 years older than River, which we said that is true. And then Lacey is 4.5 years younger than River. We said that's also true. So it would be 4.5 plus 1.5 is 6. Because look, 4 to 10. Also true. River's age added to Lacey's age equals Anna's age. Let's see. 8.5 plus 4. Well, that's going to equal 12.5. Right? That's not right. Anna is 10. So that's our answer because that's the one that's not true. Okay? Let's look at the next one. The model below shows the number of stickers in Alicia's collection. She has 2 kinds of stickers. Which equation shows one way to find the difference, math action word, between the fraction of stickers that are hearts and the fraction of stickers that are flowers? So they want the difference, which means I'm going to be subtracting. Don't even look at H and J because H and J are doing what? They're adding. I don't want to add. I want to subtract. So let's see what fraction, let's see how many stickers are all together, and that will tell us our denominators, right? So we've got hearts and flowers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 all together. So both of their denominators should be 12. Okay, hearts, we've got 1, 2, 3, 4, 5, 6, 7, 8 out of 12 are hearts. Okay, and then 1, 2, 3, 4 are flowers. I know it's hard to see. We've got 8 out of 12 are hearts, and then 4 out of 12 are flowers. Okay? So I want you to make sure that you understand how I got to that. I got to that because I counted how many there were all together, and that was my denominator. That's my total, right? And then the part that were hearts is my numerator for the hearts fraction. The parts that are, the number of flowers there were is the part of the fraction of stickers that were flowers. So that's where I got 4. So now let's look. So we want to subtract 8/12 minus 4/12 to find the difference between those two amounts, right? Well, whenever I add or subtract fractions, does my denominator change? No, it does not. It stays the same. Then I just subtract the top like normal. What's 8 minus 4? 4. Well, here's my equation. Which one of these options tells me what that equation was? F does. Okay, the answer is F. Let's look back here. Lily is given a weekly allowance. She budgets her allowance as shown in the diagram below. She's got apps, clothes, charity, snacks, and shoes. Which equation shows one way to find the fraction of Lily's budget to be spent on clothes, shoes, and charity? Okay, so I've got 3 parts here. So I can automatically eliminate A and D because I only have 1, 2 parts, 1, 2 parts. Okay, so let's find so we've got clothes, shoes, and then charity, right? So first of all, what's my denominator going to be on all of them? I need to find out how many things that she's spending her money on. 1, 2, 3, 4, 5, 6. So that's going to be my denominator on all of them. How many of these are clothes? 2 are clothes. How many are shoes? Just 1. And then how many are charity? Just 1. So if they want to know, all of these, right? They want to know how much money is going to be spent on all of this together. So am I going to be adding or subtracting? Adding. So I need to add 2/6 plus 1/6 plus 1/6. And then if I do that, I see that 2 plus 1 is 3, 3 plus 1 is 4, so it looks like B is my answer. C is not my answer because, look, there's 2 clothes. If there's 2 clothes, then I have to account for both of them and make a fraction of 2/6, not 1/6. All right, so the answer is B. Let's look at this last one. 2 points are shown on the number line. Which equation shows one way to find the distance between points M and point C? You better have bumped up this number line. Okay? Bump, 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 bump. Stop right here. This is between 0 and 1, so what is my fraction? Fourths, right? So this would be 1/4, 2/4, 3/4, 1. 1 and 1/4, 1 and 2/4, 1 and 3/4, 2. Do you see how this is a clear division of a whole right here? Are we seeing that? Yes? Okay. Which equation shows one way to find the distance between point M and point C? So here's point M at 2/4 and point C is at 1 and 3/4. So first, do you see what kind of fractions we've got here? We've got impropers. So let's go ahead and take 1 and 3/4 and convert it to an improper fraction. Remember how to do that? I'm going to multiply the whole number times the denominator. 1 times 4 equals 4, and then I'm going to add it to the numerator. So I've got 7, and then my denominator stays the same, fourths. Okay? So this would be 7/4 minus 2/4. Look at what I have right here. 7/4 minus 2/4. Denominator stays the same with 4. 7 minus 2 is 5. That's where we get G. All right, y'all. Good job. Thanks for watching. See you tomorrow.